Ugh, I really hope it starts snowing soon. I need there to be a snow day tomorrow.
Need there to be a snow day?
Yeah, there's this, calculus test about approximating integrals, and I, really don't want to take it. It's no matter how hard I study, it never makes sense. I mean, rectangles on a curvy graph? It's like whoever thought of that purposely thought of that to torture future calculus students for years to come.
Wait a minute. Approximating integrals using rectangles on a curvy graph? Are you talking about Riemann sums?
No. I don't like that look in your eye. Whatever you have planned, stop it right now.
I don't know what you're talking about. I was just going to suggest that we calculate the chances of having a snow day tomorrow.
Using snow day calculator?
Using calculus?
Oh no! Oh no! So scared of going to school, hope the snow never ends. Just waiting on the cancelled school day letter to send. Studying oh so much won't do nothing for me. You say it's unlikely, I say just wait and see. So let me be, and please set me free, oh yeah.
Riemann sums, Riemann sums. Add 'em up, add 'em up, add 'em up, add 'em up. Riemann sums, Riemann sums. Add 'em up, add 'em up, add 'em up, add 'em up. I got rectangles on my graph, add the areas up and have a laugh. I got rectangles on my graph, and the trapezoidal sum and divide in half. Riemann sums, Riemann sums. The integral approximation. Riemann sums, put to use situation.
I tried to learn this stuff about 1,000 times.
My Riemann sums inspired this rhyme. To calculus will be up in no time. Riemann sums, Riemann sums.
It's that I do not know how to tell left from right and then midpoint all. So let me be, and please set me free, oh yeah.
Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up. Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up. I got rectangles on my graph, add the areas up and have a laugh. I got rectangles on my graph, and the trapezoidal sum and divide in half. Riemann sums, the integral approximation. Riemann sums, put the use in the snowy situation.
And now my faith is shaken 'cause of all these mistakes, yeah. They keep me staring at the sun. I'm desperate and confused, still haven't learned from you. I'm seeing tears and now I think it's time to run. Why do you do what you do to me, yeah? Why can't you be easy, yeah? Why do you do what you do to me, yeah? Why can't you be easy, yeah?
Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up. Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up. I got rectangles on my graph, add the areas up and have a laugh. I got rectangles on my graph, and the trapezoidal sum and divide in half. Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up. Riemann sums, add 'em up, add 'em up, add 'em up, add 'em up.
Some hours and many tears later.
So if it's 5 p.m. right now, and they make the call at 5 in the morning to tell whether or not there's going to be a snow day, we know that there needs to be 30 centimeters of snow on the ground by 5 a.m. in order for a snow day to happen. We can use the estimated rate of snowfall for each time during the night in order to use calculus to approximate how much snow will be on the ground at 5 a.m. So here on our table, we can start with the left Riemann sum, which is going to take the difference between our 2 points and then use the left point as our height of the rectangle on our hypothetical graph. So that's going to be 2 times 0 plus 2 times 6.2 plus 2 times 8.8 plus 2 times 8 plus 2 times 3.2 plus 2 times negative 4.4, which is going to total about 44.2 centimeters. Next would be the right Riemann sum, which is going to use the same subintervals on our table, but use the right point as our basis instead of the left point. And that's going to be 2 times 6.2 instead of 0 plus 2 times 8.8 plus 2 times 8 plus 2 times 3.2 plus 2 times negative 4.4 plus 2 times negative 16, because I wrote that wrong based off of the weather report that I checked for this, which is going to equal about 12.2 centimeters. We have midpoint sum next, which instead of using 7 subintervals, is instead going to use the subintervals between the two. So instead of using a point to the left or the right, we're going to use the point in the middle. This can only be done when we have even subintervals for our entire table, which in this case we do because they're going up by 2 each time. And so instead we're going to take 4, because our distance between the x values is 4 instead of 2 like it was for here, and we're going to use the middle point in between. So 4 times 6.2 plus 4 times 8 plus 4 times negative 4.4 to give us an approximation of 39.2 centimeters. A trapezoidal sum, instead of taking the left or the right or the midpoint, instead uses the average value between each point instead. And so that's going to do the space between the 2 points. So we have the same subinterval of 2, multiplied by the 2 approximations of the rate of snowfall added together. So 0 plus 6.2 divided by 2, because it's going to make a trapezoid to find the average in between. Now those two are going to cancel out essentially in the end, but just so you can see where they're coming from, because if this number was something other than 2, you would still have to be dividing by 2. Here, we can add them all together. 2 times 6.2 plus 8.8 over 2 plus 2 times 8.8 plus 8 over 2 plus 2 times 8 plus 3.2 over 2 plus 2 times 3.2 minus 4.4 over 2 plus 2 times negative 16 minus 4.4 over 2. And that approximation is going to equal 28.2 centimeters. Finally, we have Simpson's rule. This one is usually going to be the most accurate and the closest approximation to the actual amount of snowfall. It can only be used when all of the subintervals are of the same length, which in this case it works because it has a subinterval of 2 for each. So the change in x, or our subinterval, which is 2 over 3, times the first approximation, which is 0, plus 4 times the second approximation, 6.2, plus 2 times the third, and we alternate back and forth for each of our data points. And it only works when you have an odd number of data points because of the way that the pattern works out. So it can't be used in all situations, but thankfully for us, it works out fine. And then the final one is going to be, there won't be a 4 or 2 multiplied by our final data point. It will just be the number on its own. And the whole thing is multiplied by 2/3, because again, 2 is our subinterval, and 3 is just part of the equation for Simpson's rule. And that's going to approximate 31.9 centimeters.
Oh! So if the Simpsons rule approximation is the most accurate, then that means we should have over 30 centimeters of snow tomorrow. Wait a minute. That means you tricked me into doing calculus for nothing, you sneaky.
But look, now you don't have to study for when the calculus test gets rescheduled.
You're right!
And that's the power of calculus!
Milo eventually went on to pass his calc test. After so many people asked for his secret about learning Riemann sums, Milo and Lauren went on to become a math rap duo. The power of calculus went on to become the most famous math rap duo the world had ever seen, because they were the only math rap duo the world had ever seen. Rumor has it they're still out there somewhere making math raps today.